dear student friends. Uh, Welcome back to the second session of this solid state physics. In the last video lecture, I have already discussed about the definition of the crystal. So, what is a crystal? Crystal, it is a solid. It is a solid and composed of a periodic array of the atoms. Composed of a periodic array of the atoms or molecules or ions. That is, we are going to call it as a crystal. And what is a crystal structure? Here the crystal structure, it is the atomic arrangement in the crystal. It is the atomic arrangement in the crystal is called the crystal structure. Actually, I told already we will discuss in a about the crystal structure in the next lecture. So today I am going to discuss about the what actually crystal structure is. So already we have discussed about the definition of the crystallography. Crystallography, it is the science and which deals with the structure of crystalline solid. Which deals with the structure of the crystalline solids. That science we are going to call it as a crystallography. Here we are going to study the crystal structure and some of the physical properties of the crystalline with the help of that is a X-ray, electron beam and neutron beam, some other instruments. So here we are going to with the help of this crystallography we are going to study the crystal structure and some of the physical properties of the crystalline solids. And next one that is a these are the basic concept of this crystalline that is a this solid state physics, you can say it as a. And what actually crystal lattice? So here the crystal lattice means the regular pattern of the points, which describes the three-dimensional arrangement of particles, in a crystal structure. Here particles means it may be atoms, it may be ions, or it may be molecules. In a crystal structure is called a crystal lattice or a space lattice. Let us once again I am going to repeat the statement. It is the crystal lattice means it is the regular pattern of the points, which describes the three-dimensional arrangement of the particles. It may be ions, it may be molecules, or it may be atoms. In the crystal structure is called a crystal lattice or a space lattice. Especially we are going to mention space lattice in the three-dimensional. Here let us understand what actually crystal structure. I hope you already very familiar with our Indian culture. Every morning the women used to draw the rangoli in front of their house. Before going to draw the rangoli, they have to make some dots. Okay, then they are going to join it. Actually each dot have the same distance, right? So similarly here I have considered one a 2D lattice, or we can say it as a plane lattice also. So in the 2D lattice the arrangement of these are the regular pattern of the points. These are some points. Actually it is a imaginary points. Here these are the points. The successive difference between along this direction is A. Okay, and the successive difference between along this direction I am going to consider in this direction, that is B. If the distance of this point from the origin, how I am going to calculate it, that is the distance of this point from the origin, that is I am going to take it as that is NA. So here N is nothing but 1, 2, 3. Okay, and the distance remains same, right? And similarly here I have considered one more example, that is a 3D lattice. Okay, actually there are three-dimensional lattice. It is a two-dimensional, right? And let us discuss in a detail about this. Okay. Here, if we consider that is these points in the space, then the distance between will be same. Here I have considered the distance between these 2 points is same. The distance between these 2 points is that is also A, and distance between these 2 points is also same. And here further I am going to consider the nth point in the same direction. This is the nth point I have considered. Okay. Now, so actually, what is the distance from this origin? This point is I am going to consider it as a origin, and that is nothing but we are going to the distance of this point from the origin is NA. NA. Here A is what? A is nothing but a periodicity. It is nothing but a periodicity. So that periodicity is always same, and this N is an integer. I'm going to say it as a 1, 2, 3, 4, and those lattice points. Okay, and now here this is all about the crystal lattice. In general, we can say it as a that is a lattice also, lattice points. So our crystal lattice, and actually these crystal lattice are the imaginary points. These are the imaginary points which describes the crystal structure, which describes the crystal structure. Okay, and next one is a basis. We'll discuss about the basis. What is a base? So, what is a base? Actually, basis is an atom or a group of atoms. Basis is an atom or a group of atoms. So, better I have to write it as a basis is an atom or group of atoms. Uh, Let us understand. So, how the crystal structure is going to be formed? Already I have told that is crystal structure definition. So, how the crystal structure is going to be formed? Initially, we have discussed the crystal lattice, and these are the bases. Basis means basis is an atom, or it may be a group of atoms, to make the crystal structure. So, to make the crystal structure, I am going to consider some of the lattice points. Okay, these are the lattice or crystal lattice, and here I am going to consider that is a 2D basis. These are the atoms, 2D atoms, and these atoms are placed in the point in the on the lattice points. Okay, now the formation of the crystal will be looks like this. Here, better I have to draw here only. After combination of this one, so again I am going to draw this one. So and so on. The same. So this is a crystal structure. Crystal structure. This is the formation of the crystal structure. These are the lattice, crystal lattice, and these are bases. So here the crystal lattice plus basis is equal to crystal structure, or we may define it as a crystal structure is formed by the addition of the crystal lattice to the bases. And here actually base is nothing but I have told that it may be a single atom or a group of atoms. Let us try to understand. Here in the classroom there are the empty benches. These empty benches are separated by same distance. Okay, along the x-axis the distance between I am going to consider it as that is the same distance, and along y-axis the distance between the desk is again it is remains same. Then these empty benches I am going to consider it as a crystal lattice. Crystal lattice. And these bases are nothing but I am going to consider as a students. So students come and occupy the space, then it becomes a crystal structure and it becomes the formation of the crystal structure. I hope you may familiar with some of the games. Initially we have to play the game in with the help of some small balls. In a one tray is there, and in the tray we are going to place those small tiny balls, and we have to make some structure. I hope you may remember these childhood games. So here that is also nothing but we are going to call it as a crystal structure. Actually those empty spaces are nothing but we are going to call it as a lattice. Crystal lattice. Crystal lattice is nothing but that is imaginary points. Okay, these are the imaginary points or the points which describes the three-dimensional structure. Okay, and these are the empty spaces, nothing but a crystal lattice points, and bases are nothing but the small tiny balls which we are going to place. So that is a base. Now after placing those balls in the empty space, then it becomes one crystal structure. So this is all about the crystal structure. Crystal structure is nothing but the addition of the bases with the crystal lattice points. Okay. Now let us discuss about the crystal translation vector. Let us discuss. Okay. The next one is a crystal translation vector and lattices. Crystal translation vector and lattices. In order to represent the lattice points in a space, the coordinate system is required. The coordinate system is required in order to represent the lattice points in the space. The coordinate system is required. So, especially we are going to Cartesian coordinate system is nothing but a x, y, x axis, y axis, z axis. Here we are going to represent these that lattice points in a space. We need some coordinate system. Actually, all the lattice points in a space can be generated by the translating the three non-coplanar unit vectors. Three non-coplanar unit vectors. The three non-coplanar unit vectors constitute the coordinate system. Three non-coplanar that is directions constitute the that is we can say it as a coordinate system. And here I have considered this is a linear lattice. In this linear lattice, there is a row points. It is a row points repeated by the regular interval at a distance d. Sorry, regular distance at a. Okay, and this is called, we are going to call it as a linear lattice. Let me repeat once again. A row points repeated by regular interval a. Regular interval a, and it is called a linear lattice. It is called a linear lattice. If the linear lattice points are repeated at a regular interval, in other direction, let us consider this is a linear lattice. The row of points in this direction, so this distance is a. Here also distance is same. Here also distance is a, and again these linear lattices are repeated in the other than the previous direction. So this direction is I am going to consider as a b, or we can say it as a this is another coordinate system. Okay, and this two-dimensional array of points we are going to call it as a plane lattice. We may call it as a plane lattice or 2D lattice. And in the same manner, if the plane pattern of the lattice points, are repeated by the third non-coplanar translation at a distance c, then three-dimensional space lattice is generated. Here let us consider, actually this is a linear lattices, same distance, and this is a I am going to consider it as a plane lattice, and again here I am considering the plane lattice. It is repeating in other direction. It is repeating in other direction. I have not taken all these structure. I have only considering this structure. Okay, this is one a plane and this one is the other plane, and this plane it is at a distance, that is I am going to consider it as a C. Okay, so here the plane pattern is repeated by the third non-coplanar translation C, that is a three-dimensional space lattice is generated, right? And so in a especially in a plane lattice, if I want to find out the translation vector of any point, translation vector of any point, so let us consider the translation vector of this point, the translation vector of this point. How I am going to calculate it? So just for the consideration, this is the origin, this point is a origin. So how would like to calculate the, now I would like to draw one line, and this is a translation vector. So now I would like to write it as a, that a translation vector, the point, so the position vector of this lattice point, the position vector of this lattice point, that is nothing but t is equal to, here there is a and this one is a b. So better I would like to write it as a n1a plus n2b in general. For this case I am going to consider here a 1 is there, here also 1 and 2. Okay, so this is 2a plus, and here there is 1b. So the position of this lattice point from the origin, that is t is equal to 2a plus b. The position vector of any lattice points we are going to find out in this way in the plane lattice. So similarly, and so what about these n1 and n2? The n1 and n2 are nothing but integers. So that is a integer values which represents the number of lattice points, which represents the number of lattice points. Here the number of lattice points 1 and 2. Here the number of lattice points, that is 1 only. Okay, and here that is a lattice, and here a and b are nothing but we are going to call it as a that is a and b are called primitive. Okay, or we may call it as x or primitives. And similarly in the three dimensional, if the translations along a, along b, along c regarded as a vectors, the three translation directions are selected as a crystallographic axis, x axis, y axis and z axis. Okay, and here the respectively, now I will better I have to draw the diagram first, then it is easy to explain for you. Okay, these are the lattice points. So I am only indicating some of the lattice points only. Okay, now here if I want to find out the position of the any lattice point in a space lattice, so this distance is nothing but a, and this translation vector, that is b, and this is a c. So for example I have considered the position vector of this point, and this point I am going to consider it as a origin. From here to here, this is nothing but a t, that is a translation vector. T is equal to, now I would like to write it as a n1a plus n2b plus n3c. Here a, b, c are, we can call it as a, that is a different directions, the change in the different directions, or a set of, sorry, here a, b are, that is a, what I have already told, that is a these a, b, c are primitive, that is a primitive. I already have told that primitive, or we may call it as a translation vectors. And here This n1, n2 and n3 are nothing but we are going to call it as the integers. Integers. The change in along the a direction. The change in along the n2 is changing along this direction, that is a b, and n3 is the change in along the this direction. So here the translation vector, the position of this point, so that is t is equal to n1a, n2b and n3c, and this is all about the crystal translation vector and lattices. Okay, in the next video lecture we will discuss about the unit cell, and that is a primitive lattice, and some of the remaining things we will discuss in the next video lecture. Okay, thank you.